If you look at China as a country whose economy is actually doing very well, they're commissioning a new coal-fired power plant every 5 days. So that's for the next 8 years at least. So you've got a strong growth in the kinds of energy consumption, and you certainly will see that in particularly in China. The U.S., if you'll notice, is already a fairly high consumer of power. And last but not least, we have some companies with modest growth here. India, for example. So we have things that need to be adjusted. Well, how much will solar be a part of that solution? Well, we're certainly growing. If you look at production, you see an interesting curve here. Okay? If you look at just Europe for a moment, you'll see that those growths are relatively phenomenal in terms of the PV production. You know, starting back in '99, you've got growths over 30%. It's no wonder that venture capitalists are now interested in the photovoltaic industry. They've had remarkable returns on their investment for the last few years. How long will this continue? Well, that's an interesting question. You know, I'm not prepared to answer that. I don't really know how long the industry will continue to grow and at what rate. Well, why did it do that? And that is an interesting question. Why did the industry grow so much? And frankly, politics did play a very strong role in the growth of the photovoltaic industry. You had both a Japanese subsidy program and you had a German feed-in tariff program. That was basically not to take taxpayer money in the upfront construction costs, but to pay back for the electricity generated by a system at rather high cost in the beginning, tapering down to lower costs in future years. I thought it was actually a very brilliant way to fund the investment you have in photovoltaic energy. You have photovoltaic systems that are insured. Some people are sure for 20 years, some for 25. Okay. These are the insured years of a photovoltaic system. The one we have working at NASA Glenn has been there for almost 40 years. So, and it still works. If you look at the change, and this is the year 2006, this is 2007, you will see that there has been a change in the hierarchy of solar cells production. There was a very definite lead in Japan, and they lost it to Germany with Q cells. The Japanese still have a very strong involvement in Sharp and Kyocera, but now you see Chinese companies playing a very strong role in photovoltaic production. And you see the company First Solar, which is just in Toledo, Ohio, now being the 5th largest supplier of photovoltaic modules in the world. The modules that they supply are not silicon at all. They are cadmium telluride modules. Now, there was a reason for that, and we'll come back to that story momentarily. We also have now in 2008, having read some of the later advances in PV production, SunPower with its crystalline silicon is now number 10 on this list in 2008. They haven't produced the whole list because of course, we haven't finished 2008. The government actually tried to do something. They had a program which they called the Solar American Initiative. They had an interesting approach. Their idea was to to take the levelized cost of energy down to the utility market prices. So for residential, that was 10 cents a kilowatt hour. For commercial, it was 8 cents. And for utility, it was 7 cents. And what they really did was accelerate what they had planned to do from the first conception. And that is, they wanted this to happen by 2015, not 2020. Now, if you look at the cost of putting up a photovoltaic system, and we use the Japanese as an example because they provided some very interesting statistics. Look here, okay? The module itself is what, 35% of the cost? But you have engineering and installation and mounting systems. This is all just getting the system up there at about 25% of the cost. And the inverter part, if you're grid tied, at 30%. So just making the modules cheaper won't get you the lower costs for the system. You've got to make all parts of the system better. Let's look at that. Silicon, right? That's the one primarily in place today. If you look at where the research on silicon solar cells have gone, you see you get 3 different types of it. You get a single crystal array. You can have a polycrystalline or multicrystalline array. And you can have a silicon thin film, or thick film as they call it there. And these are some of the efficiencies. What you see is you're up to about 24% for silicon. The other thing that you see when you put all this together is that when you start manufacturing something, and this is a general rule, it doesn't have just to do with photovoltaic modules, it has to do with making widgets. If your production doubles, the cost goes down by 20%. And that's a rule of thumb kind of argument for what has happened in photovoltaic modules. The cost has gone down from 1976, and if it continues, but you'll notice it's starting to deviate there, so one might thus say, well, maybe it's going to plateau, folks. It's not going to go that much lower. But if it were to do so, what kinds of things could we do to help it along? Well, we might use less silicon. We might lower the silicon feedstock prices. We might make thin films. We could do a lot of manufacturing processing, and we could improve the performance of the whole module. Every time you improve the efficiency, remember, you make a great gain in terms of the costs per kilowatt hour. So, if you did all of that, you might imagine that you might reduce it further. The problem that arose was really quite simple. If you look at, go back 10 years roughly, you will see that what the solar industry was doing was using the waste scraps from the semiconductor industry. And there was waste aplenty, so they would take all those bits and pieces of silicon, and they would then, from that semiconductor grade material, they would make a solar cell grade silicon to make photovoltaic modules with. Well, what happened was a couple of things. First of all, the semiconductor industry got more efficient at making its transistors and circuits and everything. Remember, they're getting smaller, right? They're getting smaller with their circuits, and they were beginning to utilize the silicon more efficiently.